So I'm just going to give you the steps right away, like step 1, step 2, step 3, and we'll just jump into it. So steps. Okay, steps. So 1. Step 1 is to find the, and this has a name, okay? It's called, I have to look at my notes to spell it. I don't know how to say that word? Yeah, auxiliary equation. If you have a hard time saying it, there's another word, it's characteristic. So the auxiliary equation or characteristic equation. So step 1 is to find that. So find what's called the auxiliary or characteristic. I'll use both interchangeably. I just tend to use both. So find the auxiliary or characteristic equation. We'll come back to that. 2, I just want to go through the steps briefly, and then we'll just start doing some problems. So 2, you solve it. You solve it. This is what it's all about. It's all about solving equations. So next time we'll review like the rational roots theorem and all completing the square, all that stuff, all that basic algebra stuff. So solve it. If you get, so there's 3 cases, right? There's 3 cases. Case 1, you get distinct real roots, like 3 and 4. So different answers and they're both real numbers. So distinct real roots. So if that happens, right, if you get distinct real roots, then the answer is y equals, oh, I need to give them names. Let's call them m1 and m2. So maybe m1 is 4, m2 is negative 6 or something. They're just real numbers and they're different. In this case, the answer will be c1 e to the m1x plus c2 e to the m2x. Okay, so if you get different answers, that's the answer to the DE. Like you just write it down. It's super easy. Okay, so if it gets 4 and 5, you would just get e to the 4x, e to the 5x. It's that simple. Where does this come from? I don't know if I'll have time to show you today. We'll see. I can either show you or do a problem. I think I just want to do some problems. 2. If you get a repeated real root, so a repeated real root, say m. So like if you get m equals 3 twice, I mean, so how does that happen? If you had something like this, right? If you had something like this, you get m equals 3, and the multiplicity is 2. That's called the multiplicity. So multiplicity 2. So if you get something like this, if you're solving it and you get this, this number is called the multiplicity. So if you get 3 twice, it's m minus 3, m minus 3. In that case, the answer is c1 e to the mx plus, and because it's repeated, you put an x. So it's c2x e to the mx. If it's multiplicity 3, then you do it again. You put x squared. So every time it's repeated, you put an extra x. Okay, you'll see when we do problems. The reason is that these have to be linearly independent. And so putting an x there makes this function and this function independent. Yeah?
Are we just not doing 4.2?
Yeah, we're not doing 4.2. 4.2, good, so cool that you asked. 4.2 explains a constructive way to come up with this answer action. That's what 4.2 is actually about. This. Oh, it's psychic. Oh, yeah, it's creepy. So 4.2 shows you how to come up with this. Like I'll try to explain it maybe today, like how to get this, but I can't without doing 4.2. 3. Yeah, we'll skip 4.2. We also skip 4.5. 3. If you get complex conjugate roots, so complex conjugate roots. Complex conjugate roots. Let's say the roots are alpha plus or minus beta I. So I'll just call it m. So we have 2. We have like 2 plus 3i, 2 minus 3i. Those are Greek letters. It's alpha plus or minus beta I. Alpha plus or minus beta I. I wish we had like 3 hours, but we don't. But it'd be really cool. It'd be awesome because we could do this all day. Then the answer is c1 e to the alpha x cosine beta x plus C2 e to the alpha x sine beta x. E to the alpha x sine beta x. So those are the three cases. So in theory, you could now do all of the homework, like in theory, with just these formulas, like with nothing else. Like in theory, you could just go in there and do all of it. But I have to show you how to get the auxiliary equation. So we have 7 minutes, so I can explain where this comes from, or I can just do some examples. It's kind of a tough spot. Maybe I should just do some examples. And then next time, if you want, I'll show you the motivation for this. It's really beautiful where this comes from. It's like really, really nice. But if we do it, then you won't see any examples. So it's like, oh, it's painful. But let's just do some problems. So here's just right now. Just jump into it. So let's do it. I'm just going to call them examples. Oh, no. Let's do homework problems, right? Why not, right? Homework is better than anything, right? I mean, that's the best thing to do. Let's see. This is, where is it? Homework. Open student view. This is DE 4-3. We have 7 minutes. We can do this. Number 1. Oh, I don't like it, but I guess we should do it. So number 1, let's do it. Number 1. Of the homework? Yeah, I know. It's just, I don't know. Like, it wouldn't be my first example, right? This would not be my first example, but it's the homework's first example. I wanted to do something easier. So solve this DE. Solve this DE. It's a little bit harder than what I would do. I would do an easier one, I guess. It's not as instructive as the example I wanted to do, so I guess. So solution. So step 1, you have to find the equation, right? It's called the characteristic or auxiliary equation. So I like to use the letter M. Some people use the letter R. So it's just 3. And here's the trick. Whenever there's a derivative, you just match the power. So it's the second derivative, so it's the second power. It's just matching, okay? It's just matching. It's really easy. And then first derivative is just the first power. And that's equal to 0. Yeah, this is not the easiest problem, I think, for a first example, but it's still really easy. Okay, so 2, 2, 1, 1. That's step 1. That's the auxiliary or characteristic equation. Okay, and then now we have to solve it. So we'll solve it. What can we factor out in this case? M. Yeah, so let's do it. So M, parentheses 3m plus 1, and this is equal to 0. It's equal to 0. Yeah, I'm glad we started this section. This way, if you're bored and you have time, you can like do a couple. You have a product equal to 0. You set each factor equal to 0. I'll show the steps. Why not? M equals 0, or you're supposed to put an or there, but you don't have to. So you get m equals 0, and then in this case, we can solve for m. Right? Subtract 1 from both sides. So minus 1, show all the steps. So 3m equals minus 1. Divide by 3, right? Divide by 3. So divide by 3. So we get m equals negative 1/3. So we have 2 different answers to the characteristic or auxiliary equation, and they're both real. So recall that whenever they're distinct real roots, the answer is always, it's just e to those numbers. So it'd be c1 e to the 0x plus c2 e to the negative 1/3 x. We're almost done. Right? Just you put them there in the exponents. That's going to be the answer to the question. Like, we're done. Right? The only thing is we can simplify this a little bit. What is e to the 0x going to be? 1, yeah, because it's e to the 0, right? So this is going to be y equals c1 plus c2 e to the negative 1/3 x. That's it. That's it. That's number 1. Yes, Ryan?
What would you need to be able to find constants?
You would need initial conditions. So like, if someone said y of 0 equals 2, y prime of 0 equals 0 or 1, then you could do this and you could find the constant. That's going to come up in the homework. Good question. Any questions on this one? It's really simple. Yeah?
So this one was case 3, the complex.
No, it's the real, distinct real roots.
What's the difference?
They have to be, it has to have the eyes. Right. Let's do one like that. Here, check it out. Say we have, I'm going to call it an example. I'll make one up. Y double prime plus 4y equals 0. So solution. So in this case, step 1, as always, is to find the auxiliary or characteristic equation. So it'd be m squared plus, and it's just 4, okay? It's m, and it's the 0th derivative. So m to the 0 is 1. So whenever you have a y, you just put the number, basically, right? You just put the number when there's a y. That's why when I saw this one in the homework, I'm like, it's not the best example, because it's missing the y. Right, this is not the best first example either, but it's decent. Okay, so again, m squared, there's no derivative, so just a number. Subtract the 4, so m squared equals -4. Whoa, it's like a pendulum, it's a whole math problem. Take the square root. Oh, so you get a plus or minus. Anyone know what goes here? What's the square root of -4?
4i.
No, almost. 2i. It's 2i. Right? 2i. So you want to write it in the form. It's really 0 plus or minus 2i. Remember, it has to match the formula, which was alpha plus or minus beta I. Right? That was from the formula. So alpha would be 0, and beta is 2. Right? It just matches, right? Beta is 2. So yeah, Ryan?
If you had another m, that would be your alpha.
Let's say that again.
If you had like another m.
Yeah, so if I had like 3 plus or minus 2i, then alpha is 3 and beta is 2. If I had something like that, that would be the case. Like that's the alpha always, right? There was no alpha. Alpha was 0. Okay, good question. So now let me write down the formula just because it's our first example. I'm glad we started this today. Even though we're barely doing it, next time it'll be like, okay, we did a little bit of it. So it's better than nothing, right? So I'll write the formula down again. Eventually, like you stop writing the formula down because you get really good at this. I'll pause. We got time. We still got 2 minutes. Still got time. We still a minute. 30 seconds.
That went up fast.
Yeah, I was counting wrong. When you plug in 0 for the alpha, you get 1, right? So you're just going to get C1 cosine of 2x, right? Because e to the 0 is 1, right? Alpha is 0. Alpha is 0, beta is 2. And then here we have C2 sine 2x. And that would be the answer. So this is the complex conjugate case, Marissa. Yeah, Tony?
How did we set up the alpha beta again? Everybody?
From here? Yeah. From here? It's just whatever number is there as alpha and whatever number is there as beta always. So we were here at plus or minus 2i. So you think of it like this. So it's alpha, beta. So if it was this, it'd be alpha equals 3, beta equals 2. Okay. So alpha is always this number, beta is always this number. You see it? Yeah, it's worth it. So that's it. Sorry we went over time. Next time we'll start over, right? We'll do this again. Yeah, oh, this is so nice without this thing following me. All right, let's do it. Let's get started. So today we're going to pick up, we're going to continue what we did last time, right? So let's do it. Let's keep going. So 4-1. Continued. So maybe we'll start with a, hey, right. We'll start with a recap of what we did last time, just like a quick refresher, because we did it at the end of class. So, and then we'll start doing some homework problems. Hey, what's up, guys? So just a recap. So recall from last time. So recall. Whenever you have the characteristic equation, which is also called the auxiliary, be careful with your backpack, by the way. Yeah. So whenever you have the characteristic equation or the auxiliary equation, you have a couple different cases. So case 1, if you get 2 different answers and they're both real numbers, so if you get distinct real roots, so distinct real roots, so like 2 and 3, 4 and 5, 6 and 7, square root of 2, square root of 3, say m1, comma m2. So if you have distinct real roots, then in this case, the answer is just going to have c1 e to the m1x, c2 e to the m2x. So it'll be c1 e to the m1x. And we did this last time. I'm just writing it again as a refresher, right? c1 e to the m1x plus c2 e to the m2x. You know, as we're going through this, maybe we can do an example of each. That might be fun. Right, I'll just make one up. Why not? Just do something different. So let's do an example of it right away. So like say we had, we'll have to think now. Let's see. Oh, let's see. Y double prime. Skill.
4-1 or 4-3?
Still, oh! Thank you, Tony. It's 4. Is that worth points?
Yes.
It is? That's fine. That's fine. Okay, Tony, I'll write it down. All right. Yeah, I'll write it down after class, Tony. I don't have a pen.
It's 2 points.
It is 2 points, sure. Yeah. It's all right. Tony, right? I'll remember your name. No, I'm kidding.
Wait, are we doing double points?
Yeah, we're doing double points.
So do I get 2 points for me correctly guessing where the guy came from?
What guy?
Where?
No, that wasn't a mistake.
Well, no, but you said I get extra credit for guessing it right.
No, I was kidding. So plus. I'm sorry, Kyle. I'm sorry. So hey. So let's see. So y double prime plus what's a nice 3y prime. You don't need it, Kyle. Plus 2y.
Sure.
I know, right?
How about you guys compromise for 1 point?
So we have this. So we have this.
Try it.
Nah, you'll get an A on the next test. This next test is easier. So say we have this. Let's just go ahead and solve it really quickly. So first you have to write down that equation with the m's. So it's called the characteristic or auxiliary equation. So it's m. And what power goes here? Do you remember?
2.
2. Yeah, 2. Because you match it, right? You match the derivative to the power. It's the second derivative, so it's the second power plus 3m. Right, because it's the first derivative. Hey, you made it! I'm recapping what we did last time, just so it's good. And then whenever you have a 2y, what goes here? M to the 0, so 1, so just 2. Very good. Yeah, I'm surprised you remember that. That's pretty cool. Yeah, it's the 0th derivative, so it's really m to the 0, so it goes away, so it's 2. I actually made that up, but it works. Okay, so again, step 1, just match the order of the derivative to the power, right? Then you have to solve this. That doesn't always factor. I think we can factor this one if I made it up correctly. So I have 2 numbers that multiply to 2 and add to 3. So I think 1 and 2 would work, right? 1 and 2. And they're both positive. They're both.
2 and 1?
It's the same thing. Very good. Trying hard, huh? Yeah. I know if you get enough extra credit points, you won't even have to take the test, right?
That's the goal.
The record's like something ridiculous. It's in the 20s. It used to be 15, and then like last semester something happened. I don't know. It doesn't matter. So we get -1, but they had like a 300-point test, and -2. -1 and -2. So now we can use this formula, right? So all you do now is plug in the m's into the formula. So the answer here would be y equals c1 e to the -x. It's -1, so it's -1 times x. And then plus c2 e to the -2x. And that's it. That's it. I wasn't going to do an example. I was just going to go through this and then do some homework, but why not, right? It's good practice. And this is a good example of this particular case. So any questions? Any questions on any of this stuff? I don't know if this is on. Let me just check. It's fun how it doesn't follow me anymore. It's kind of nice. No questions? Questions? Yeah.
Does it matter which one you put the m?
No, it doesn't. No. Ever hear what Ryan said? Does it matter about the m's? So you can put the -2x here and the -x here. It's still correct. Doesn't matter. Doesn't matter. So whenever you get different answers and they're real numbers, you just do this. So if you had another one, like m equals 4, you would do plus c3 e to the 4x, right? You would just keep going for each one you get. Okay, so different real numbers, you do that. Different real numbers, you do that. Pretty easy compared to the Bernoullis and stuff. All right, 2. If you get a repeated real root, so I'll show you what this means. So a repeated real root, m. Say a repeated real root, which we'll call lowercase m. So what does that mean? That means you get it twice. So let me show you. Let me just, what's the answer? Then it's c1 e to the mx plus c2. And then you have to do something when you have repetition. Does anyone remember what we have to put here? An x. So every time it's repeated, you put an x. So if it was repeated, if it was 3 times, it would be this one, then x squared, etc. Let's do a simple example so you see how it works. Say we have y double prime plus, plus 6y prime plus 9y equals 0. Let's try this one. Y double prime plus 6y prime plus 9y equals 0. So in something like this, same thing, you start by writing down the characteristic or the auxiliary equation. So it's m squared plus 6m plus 9 equals 0. Piece of cake, super easy. Right. Yeah?
Is that u mx or e m to the x?
Which one? This one? This is e to the mx. Yep, thanks, good. So the mx is the exponent, right? And you have the x on the outside. This should factor, I believe it's m plus 3 quantity squared, I think. That should be. Right, because it's m plus 3, m plus 3. So we get one answer here. We simply get m equals negative 3. And the multiplicity in this case is 2. This here is called the multiplicity, this number here. So this is the multiplicity. So this is multiplicity 2. Multiplicity 2. So in this case, you would just use this formula and you replace m with negative 3. So it's c1 e to the negative 3x plus c2 x e to the negative 3x. And that's it. So pretty easy. Pretty easy. So different answers, you just write the answers down, right? Different answers, you write, and when it's repeated, you just have to put an x, okay? If it showed up again, let's say it was, if there was a 3 here, if there was a 3 here, then you would have to add c3x squared e to the negative 3x. So like if there was a 3 here, you'd have to go one more. If there was a 4, you'd have to add this one, then c4x cubed. You have to keep multiplying by x. It'll come up in the homework. We're going to do a lot of homework today in class, so you'll see examples of that. So any questions so far on this stuff? All right, let's do one more. Actually, yeah, third case for completeness. The last case is when you have complex conjugates as answers. So like 2 plus 3i, 2 minus 3i. So if you get complex conjugates, say alpha plus or minus beta I, then the answer is going to have sines and cosines, right? It'll have sines and cosines. It'll look something like this. C1 e to the alpha x cosine beta x. So e to the alpha x cosine beta x plus, and then C2, can you see it or no? Can you? Oh, okay. So C2 e to the alpha x sine beta x, sine beta x. So if you get complex conjugates, that's what you would get, right? Complex, like 2 plus 3i, 2 minus 3i. It's a lot of Greek letters, Have you all seen alpha and beta before in other classes? Yeah, you have.
Is that an equal sign or anything?
This one?
No.
This?
No.
This? It's a plus or minus.
Okay, yeah.
Sorry, yeah, plus or minus, yeah. So, okay, plus or minus. No, it's an equals. No, I'm kidding. No, it's a plus or minus. All right, let's do an example. How about something like this one? Actually, yeah, something like this one. Y double prime. And we did one like this last time, but I'm trying to keep it simple, and then we'll do some homework. Plus 9y equals 0. So first step is we write down the characteristic equation. So it would be m squared plus 9, right? 9 equals 0. That's the first step. Step 1. Step 1. Characteristic equation. I'm going to look at the homework. Right, and then you solve this. How do you solve this equation? What do you do? What do you do to solve this? Subtract 9. Yeah, subtract 9, right? So you just move this over to the other side. So you get m squared equals negative 9. And then we just have to take the square root, right? So you take the square root. So square root, square root. So you get m equals, and the square root of negative 9 is 3i, right? 3i. What's missing here?
Plus or minus.
Plus or minus. Very good. Plus or minus. Whenever you take the square root of a variable squared, you're supposed to put a plus or minus. It's super important, right? So don't forget that. So now we can make it match this form, you see. So you can write this as 0 plus or minus 3i, right? You can write it like that to make it match this form, see. So in this case, your alpha is equal to 0, right? 0, 0. And what would your beta be in this case? 3. Yep. Does everyone see why it's 3? Because it matches. Sometimes people will think, oh, is it negative 3? No, it's just 3. If you incorrectly chose negative 3, you would still get the same answer. Because when you plug them in here, if you put a negative in here, cosine's even, so it'll go away. If you put a negative here, it'll come out because sine is odd, and it'll get absorbed into the constant anyway. So you'll get the right answer even if you choose negative 3. Right? Kind of a weird thing. So all you do now is you plug it in here. So you get y equals c1. E to the 0x is going to go away. Because what's e to the 0 going to be? 1. Yeah. So it'll just be cosine of 3x plus c2 sine of 3x. And that's it. That's it. So we've done every single case. Right? Those are all 3 cases. Just a recap of what we started to do last time. Right. Any questions on any of these examples? In theory, now we can do all of the homework. There's harder questions, much harder. Otherwise, we just go to the next section. But these are like the easiest ones. So three basic cases. So different answers. You do this, right? You just do C1 e to the answer, C2 e to the answer. If you get the same answer and it's repeated, you have to put an x and write it twice. And if you get complex conjugates, you do this. So far in this class, all of the examples of complex conjugates have had an alpha of 0. That was on purpose to save myself time in solving it. I didn't feel like using the quadratic formula, right? Or completing the square, which we'll have to do. So, all right. Any questions? Any questions? All right, let's do some homework then. I have all of the answers to the homework so I can see like how hard they are. Let's just not mess around. Let's just go to the good stuff. Let's start with yuck. Okay, no, let's see. Wow, they're all hard. There's a lot of hard ones. I guess I should just pick one and do it, huh? What is this? Here we go, number 9. Number 9, let's do number 9. So number 9 is pretty tough. Great test level already. Do you have it up, Nikki?
Is it on 4.3?
Yeah, yeah.
D3u over dt3 plus d squared u over d2 squared minus 2u.
Wow, equals 0, right? Yeah, fun times, okay. This is what it's all about. So this one's kind of exciting, a little bit harder to see. I can't make these up on the spot. So a little bit harder. This one's going to introduce a new concept. So solution. So first thing you do is you write down that equation. Do you remember what it's called, the equation we write down?
Auxiliary equation.
Yeah, the auxiliary equation. Very good, Duncan. Extra credit. No, I'm kidding. No.
Oh,
good. No.
You gotta give us something.
No, you don't need it. So this would be m cubed, or it's also called the characteristic equation. So m cubed plus m squared minus 2 equals 0. Equals 0. So we're here. This is where people get stuck, like game over. No, so what do we do? Yeah, but it won't work. I don't think it will. I mean, good idea. Yeah, and I don't think it'll factor nicely. Like, we can't do it in our heads unless we're like a super genius. There's a theorem. It's called a theorem. From algebra, the something theorem. Do you know what I'm talking about? No, it's not a hint enough. The do you know rational roots, Kyle, good! The rational roots theorem, or the rational zeros theorem. It basically says, so when you can't factor it, right, try this. Look at the factors of this one over the factors of this one. So it's factors of this over factors of this. So it'll be factors of -2. I'm going to write it out. Factors. And we'll do a couple of these over factors of 1. And what this does is this will give you the possible rational roots. In other words, if there are answers to this equation and they are rational numbers, they're going to be on the board. Rational numbers are whole numbers and fractions, like 2 over 3, 4, -6, stuff like that. -6 is a fraction, right? -6 over 1. So factors of 2 would just be 1 and 2, but you have to have a plus or minus. So plus or minus 1, plus or minus 2. Oh, those are the factors of 2. I'm not making any mistakes anymore. Factors of 1 would just be 1, right? So plus or minus 1. Yeah, I should make a New Year, well, it's too late for New Year's resolutions, but a February resolution, no more mistakes. So 1 over 1 is 1, 2 over 1 is 2. So we get plus or minus 1, because 1 over 1 is 1, then 2 over 1 is plus or minus 2. So these are the possible rational roots. Yes, Aislinn?
It's like we did in college algebra, so it would be like if you have 1 and 5, you have like 1/5 or something.
It's exactly like in college algebra. Very good, Aislinn. Let me just emphasize that. So like say, it's not going to be that hard in this class, unfortunately, but in college algebra it was harder. But like if you had, say you had something like this, it'd be 1 over 1, 1 over 7. So you'd get 1 over 1, which is 1. 1 over 7 is 1 over 7. Then 2 over 1 is 2. 2 over 7 is 2 over 7. Then you go to 3. 3 over 1 is 3. 3 over 7 is 3 over 7. This is not going to happen though, because I mean, unless I make one up, that's harder. But I won't, because I'm not going to. But yeah, in the homework, there's always a 1 here in the homework, I think. Okay. Do you remember this? So this over this, 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 this over this. No? Okay. Anyways, so now you know. So it's always this one over this one, okay? Always. It's always last over first. Always. Every single time, okay? All right. So what do you do next? Well, you can just start plugging them in to see which one's an answer. Like if you plug in 1, 1 plus 1 is 2. 2 minus 2 is 0. So you know 1 is going to be an answer. Look, 1 plus 1 is 2. 2 minus 2 is 0. So 1 is an answer. But you still have to do other stuff. So what you're supposed to do is you're supposed to use synthetic division. So you're supposed to start checking. So let's always start by checking 1 or -1. Let's start by checking 1 because 1 is easy. So check 1. So check 1. I'll show you how to do that. And we'll do another one after this. I'll find it. So you put a 1 here, and then I like to put a little bracket like this. Okay. And then you go here and you write down the coefficients of this equation. So it'd be 1, 1. What's the next coefficient?
-2.
No. Anyone see what it is? I know. 0! Why is it 0? Because there's no m. It worked! Yes, 0m. So be really careful. That ruins everything. Then -2. Yeah, it's really sneaky. It's really sneaky. This is really good homework, by the way. Like this is something you'll definitely see on an exam situation every semester, without fail. This is something that shows up, and most people get it right. So 1, 1, 0, -2. Okay, so how do you do the synthetic division? I'll show you. So first, you take this one and you just bring it down. Just bring it down. So 1, just bring it down. And then you start the multiplication process. 1 times 1 is 1. 1 plus 1 is 2. So you bring it down. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 0 plus 2 is 2. Let me do it again. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. -2 plus 2 is 0, and we can rejoice. That's what we want. This is good. So you keep doing this until you get 0. If you don't get 0, you check -1. Okay, you just keep doing it until you get 0. Once you get 0, you know something. This means that m equals 1 is a solution to this equation. Right, that's what it means. And so it's a root. It's also called a root. Solutions are called roots. Same thing. It's just 2 different words, right? When you think of this as a function, people call them zeros. It's always the same. And if you think of the graph, it's an x-intercept. So 4 words, and they're all the same kind of, right? Zeros, roots, solution, x-intercept. Crazy, right? It's completely ridiculous. So recap. factors of this one, factors of this one, you get this. Start by checking 1. Always try 1. 1 is a good bet. If you have to bet on 1. If it doesn't work, if you don't get 0, do something else. And how do you do this? So it's 1, 1, 1, 0, negative 2. 1, 1, 0, negative 2. And then you just bring it down. I always think of like a bouncing ball for some reason. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. Boop, 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 boop. We can rejoice at 0. So we're done. So now you go here and you start at 1 less. So this is m cubed. So you start at m squared, right? It's 1 less. So it'll be 1 times m squared plus 2 times m plus 2. And that's equal to 0. Any questions on this? Because I know it's been a while. Has anyone never seen this before? Like, and never in their lives? You all never seen this? Wow, sorry. It's all right. Yeah.
So you can test which ones work by plugging them in first, and then if it works, then you can do synthetic to find the actual equation.
Yeah, Duncan's right. That's a common thing. A lot of people do that. They test which ones work first by plugging them in, and if it works, then they'll do synthetic. Because like in this case, it was easy, right? 1 plus 1 is 2. 2 minus 2 is 0, so 1 is going to work. So go ahead and check 1, because now you need this piece. Right? You need this piece. Good. Any other questions so far? You had never seen this, Ryan? Was that you who raised your hand? Never? Oh, wow. You didn't take algebra. Okay. Okay, so this probably will not factor nicely. We can't do it in our heads. I can't. We have 2 choices. We can complete the square, or we can use the quadratic formula. Do you all have a preference?
Let's complete the square.
Only in DE. Very good. That's how pros do it. Yeah, and in college algebra class, you'd never hear that. They'd be like, no! Like, yeah. Completing the square is easier, right? But it's harder to learn for people. So to complete the square, we'll subtract the 2. Let's do it. That's how pros do it, Duncan. I always tell people, it's not until like DE that people become really comfortable with completing the square. Like it takes some time. It's a hard concept to learn. When you're completing the square, you isolate this. Then you take this and you divide it by 2 and you square it. Yeah, so I'll do it over here. Well, that's actually, yeah, I'll show the work. So 2 over 2 is 1. 1 squared is 1. That's what we want, right? So you just divide this by 2 and square it. So you can do it in your head. So you just add 1 to both sides. So plus 1, plus 1. So you get m squared plus 2m plus 1 equals negative 1. Just adding 1 to both sides. Okay, this is called a perfect square trinomial. It'll always factor like this. M squared equals negative 1. It's always going to look like that. I just have it memorized. I just know you're going to have an m, you're going to have a 2, you're going to have the parentheses. And then you keep the sign. So you keep this sign. You keep it. And then you just take this number and divide it by 2 every single time. So 1. Okay, so you keep the sign, divide this by 2. Keep the sign, divide by 2. Keep the sign, divide by 2. Keep the sign, divide by 2. How do you get rid of the m plus 1 squared? What do you do to both sides in this case? Square root. Yeah, square root. Very good. So you get m plus 1 equals, and now we just have to figure out what this is. The square root of negative 1 is I. Yeah, it's I. What's missing still?
Plus or minus.
Plus or minus. Yeah, I had to say that, otherwise it cost me points. Plus or minus I. Subtract the 1. So you get negative 1 plus or minus I. I'm going to put that in a box because that is an accomplishment, and so is this, right? These are like significant milestones in this problem. So I'm going to pause. This is a really important example. We didn't do anything this hard last time. So a recap. You see something like this, and always try factoring if you can. Always try to factor. When there's 4 terms, factor by grouping is usually a good bet. Not always. It doesn't always work. You'll actually get examples in the homework where you have 4 terms, and you won't be able to factor by grouping. Like it won't work. You'll have to use this. So it's this one over this. When you do this, start checking. Keep doing this until you get 0. Once you get 0, you're good. Always start at 1 less, okay? So if this was like a 5, this would be a 4. Okay, start at 1 less. This did not factor nicely, so we completed the square. we got here. So now we can write the final answer down. So the final answer is y equals. So it doesn't matter which one we deal with first. Let's deal with this one first. So this is just a real number. So it'll just be c1 e to the x. Because it's like mx. M is 1 for this one. Okay. And then for this one here, I probably should have mentioned it. I'll mention it down here. Alpha is -1 in this case, right? It's from the alpha plus or minus beta. What would beta be?
1.
1. Very good. It's 1, right? Because there's a 1 in front of the I. Good. Good. So now we're okay. Now, so plus, now we'll do the e's and the sines and e and the cosine. So you can do e cosine, e sine. You can put the sine or the cosine first. It doesn't matter. I'll put the cosine first. So it'll be c2 e to the alpha x. So negative x, right? E to the alpha x. And then cosine of beta x. But beta is 1. So it's just x. And then c3 e to the negative x sine x. And that would be the solution to the DE. Right? That's the solution to the DE. In the next section, you'll have a function here, like sine x, e to the x. So there'll be an extra step. So the questions become a lot longer in that case. But this is a hard, like in the next section, they're not this hard. Like they're all easy. Like this step is easy in the next section. You don't have to do this in the next section. Any questions on this one? It's probably one of the harder ones from the homework. And yeah, Tony?
Go over how we got the answer. The first.
This one? Yeah, this one comes from the formula c1 e to the mx, just when it's a real number. So m is 1. And this one is from c2 e to the alpha x cosine beta x. Cosine beta x, beta x, plus c3 e to the alpha x sine beta x. That would be the formula for the second one, right? The alphas and the betas. Anyone like this stuff besides me? It's not bad, right? It's pretty easy compared to some of the other stuff. We should do another one, though. We should just do problems today. Any other questions? All right, let's do something else. What is that? That's pretty clever. Huh. Oh, I know what we should do. We should do something really tough. There's one in the homework that's really hard. I think it's, yeah, number 12. Yeah.
Is something like that difficulty like what would be on the test?
Yes. Yeah, exactly. Yeah, this is definitely, no matter what, always on the test. Yeah.
Also called reading the code.
That's something else. Yeah, we're going to be doing that next time in 4.4. Yeah, maybe. Yeah, this is definitely something you'll see on a test, for sure. Yeah, I think it's on the old test, too. There's one like this. Let's do number 12. 12 is harder than this. I think 12 is definitely the hardest in the homework. It's really sneaky, and there's no other examples like 12 in the homework. It's the only one that's like this. It's really unique. It's kind of a hard example to do, but who cares? Let's do it. So 16. Like maybe we should build up to it first, but it's too late. We've committed. Just jump into it. Plus.
16.
Thanks, Nikki. I was going to ask.
Choose on that one.
Or choose. I know. How do you say that, right? It's like plus
4y equals 0.
4y equals 0. All right. All right. Take your time. Write it down. We got time. We got tons of time. Well, it feels like we have a lot of time. So I don't know if that's true, but I should look to see when your test is. Right? It's not next week, right? It's the week after?
Yeah.
Is it really? Already?
Well, on Monday you said it was before spring break, and spring break's in 3 weeks, so 2 weeks.
What's today, the 12th? Oh yeah, it's 2 weeks from today. Okay. Okay. Yeah, we're all right. We're doing all right. Next time we'll start 4.4. And yeah, okay. We're good. All right, solution. First step is to find that equation. What's it called? The auxiliary equation, or the characteristic, yeah. So it'll be 16, that's a 4 by the way, it's an ugly 4. So it'd be 16 m to the 4th plus 16 m squared plus 4, right, 4, just 4. Whenever there's a y, it's just a number. I think it's often a step that causes problems. All right. So this actually does factor, right? If you're feeling brilliant. But if you're not, if you want to make it easier, what could you divide everything by? 4. So let's do that, because I think it'll make it easier. So divide by 4, divide by 4. This actually will factor, okay? So this will be 4m squared. 4m to the 4th. Close, but not going to happen. Not today. Not on my watch, whatever that means. Like I'm a security guard or something. Like, not on my watch. Actually, I used to be a security guard, but they laid me off. Okay, so yeah. So I had no experience. All the guys were like ex-cops, ex-military. I was like, yeah.
Someone did do something.
I would see the bad guys and run. So we have this. Yeah. Okay, this factors. How do I know that? Because I've done this problem before. That's really cheap, but it's going to look like this. Did we copy it down right?
Yeah.
You could, but you could do it without that. But you could. Yeah, we did copy it down right. Yeah, you could. This should factor like this: 2m squared, 2m squared. But you can let u equal m squared. You could do a substitution if you want. You could. I won't, but you could. So they're both pluses. Right, they're both pluses. What number has to go here in both of these cases? 1. And let's just check our work, because this was a big leap. I just did it because I said, oh, I've done it before, so I know how to do it. It's really cheap. So 2m squared times 2m squared is 4m to the 4th. That part's easy. 1 times 1 is 1. Easy. The inside is 2m squared. The outside is 2m squared. That gives you the middle 4m squared. So if you're wondering, well, what if it's on a test? I won't be able to factor it. Don't worry, right? If it's on a test, it'll be very similar. Maybe I'll multiply it by 2. Right, or something, right? Or just, slight modifications. I'm not going to work that hard to make it harder. This is already pretty tough, right? This is already pretty tough. So basically, this is repeated.
So that quantity squared.
Yeah, so it's that quantity squared. That's right. I'm going to go ahead and write it that way just to make a point in a minute. But you don't have to make that step, but I want to just to show you something. So it's this quantity squared, right? So that basically means you just set 2m squared plus 1 equal to 0. So I'll go ahead and do that. I mean, we could have done that up here, right? We didn't even need this middle step. I only wrote this step just to show you what Duncan said, because it was worthy. It was a good comment, because we're going to use it. See, because this times this is that squared, but you just set each piece equal to 0. So you're setting this equal to 0 twice, basically. So this is going to give us something that's multiplicity 2. Whatever the result is here, it's multiplicity 2. So subtract 1. Feels so weird without that thing on my neck. It's kind of nice. Freeing. Divide by 2. Divide by 2. Take the square root, right? Beautiful. Square root, m equals plus or minus I square root of 1/2. And you could totally rewrite this, right? You could totally simplify it, right? You could rationalize it, rewrite it. I'm just going to leave it and be lazy, because you could do that. You could leave it like that. Any questions up to here? The next step is the trickiest step to understand. It's writing the answer down. So we're ready to write the answer down. Okay, so here's the answer. So this is multiplicity 2. Okay, so this is 0. Let me write it like this first so you see what alpha and beta are, right? So alpha, 0. Beta is the square root of 1/2. And this is multiplicity 2. And the reason is that it shows up twice over here, right? So that's why it's multiplicity 2. Yes?
Square root of negative 1/2? Oh, no, never mind.
It's covered in there. Where did the alpha from?
Oh, from this, it's 0.
So it's like a number plus or minus.
A number. Yeah, because that's the form. So when you, yeah, good. You see it? Good. Yeah, someone else had a question? Or what was it? It was covered up?
That was just me
Oh.
trying to figure out stuff.
I was hoping I messed up. Not. Okay, no. It's good. No, it's good. No, I didn't think. Yeah, okay. So we can write, so it's multiplicity 2. So the answer would be C1. And then all the e's go away, right? Because it's e to the 0x. So it's only cosines and sines. So it'll be cosine of that. When you type this into the homework, it takes a bit of work. Notice I put a dot there for times. Just be really careful when you type it in. It's really easy to type it in incorrectly. Plus C2 sine square root of 1/2 x. I'm running out of room. Plus, so it's repeated, so you have to do it again and multiply by x. That's the tricky part. C3x cosine square root of 1/2 x plus C4x sine square root of 1/2 x. So it shows up, that's because it's repeated twice. Yeah?
So for just clarification, if we have multiple problems inside one question like we did in the last one, we combine all of those types of answers?
Yes. Yes. So like if you had another answer, m equals 7, you would add a C5, e to the 7x. And if you had m equals 8, you would add C6, e to the 8x. Yeah, you would just keep adding them on. You can combine all of those. Yeah, and this is an even harder combination in my view because this is a repeated complex root. We never talked about that. So yeah, we're essentially combining two things. And fortunately or unfortunately, I don't know which word I should use, it's the only one in the homework like this. I thought this was the trickiest one the first time I ever did the homework. I was like, whoa, a repeated complex root, like what's going on? So a little bit sneaky, And again, it comes from noticing this, right? It's 2.
Possible to see one of these on the test? Or?
Yeah, for sure. Yeah, usually this is on there. Yeah, usually you have like all the key concepts. You'll have like the rational roots theorem, a repeated complex root, and then like an easy one, and that's it. Yeah. Yep. Or maybe like a factor by grouping or something. We could do another one. Maybe we should do. Oh, I think I messed up on the first problem. Yeah. Remember that first problem we did? Well, not the first one, with the t's? No one got it though, but I put x. It should have been t, right? The first problem we did a little while ago. What was the problem with the t's? Number 9. Yeah, it was d to the 3rd u. Let me just write it really quick. Plus. And it was funny because I was thinking, oh, I'm not going to mess up this semester because I've messed up before. Minus 2u equals 0. It was this. And what was the answer? Y equals?
C1 e to the t.
E to the t. Good. Plus?
C2 e to the negative t. Cosine t.
Thank you.
Plus C3 e to the negative t sine t.
Thank you. Yeah, I can't believe I messed up. I'm sorry. So that's the answer for number 9. Because it has t's here. So, yeah.
With number 9, since I have multiplicity of 2, so we don't do C3 and C4, just repeating like the power of E. It's only when it was like the alpha and beta version of the conjugates.
This one didn't have multiplicity 2, did it?
I thought it did.
That was a different one, wasn't it?
Should that be d2u dt to the second?
Where? Yeah. Okay. Yeah, I'll just give the whole class some points. So 3 points for my other mistake too. Okay, so 3. 4.
You gotta do it on even numbers.
Fine, 4. Okay, I'll delete this. just delete. No, I have to delete this. I can't remember to delete. This might not even be recording right, so it doesn't matter. It's whatever. It's not going to go on the internet. Was it repeated?
It's like when we did it, it was m plus 1 squared equals negative 1.
That was a different one, wasn't it?
No, it's the same.
Oh, that's not multiplicity 2 though. It was this?
Yeah.
That doesn't mean multiplicity 2. Multiplicity 2 is when you have something like this.
So only equal to 0?
Yes.
So if it's equal to a number, the multiplicity.
Right, it's got to be equal to 0.
Not a 0.
Yeah, right. I got you now, I understand. Yes, okay, so was it 4 for the whole class? I should write it down because I'm going to forget. I will forget. Does anyone have a pen? Or
Pencil?
so last time you all had points too, or no?
Yeah.
You did? How many?
You guys had like 2 or something? I don't know.
Did it? Did you?
I think it was like 20.
All right, so I'll find it. I don't trust you. All right, so let's do something else. So yeah, sorry about that. It's funny because I wrote it on the board and I thought, I remember one semester I messed up. and then I messed up again. So, because I have made that mistake before. All right, let's do number 12. 12 is going to be, I think writing down number 12 is going to be harder than doing it.
We just did it.
Oh, not 12, sorry, number, number,
We won't count that.
no, number 13. It's the next one, 13. Can someone carefully read it to me and be honest? Yeah, you're the reader. No,
If you over D are the fifths.
R, it's R this time?
Yes.
Okay, I'm not gonna mess up, okay.
What is it really?
3, and then we're gonna have 4s.
3s? Like this?
No, 3 on the front, sorry.
It's okay, 3, oh, and then a 4 here?
And then they're all 4s.
Okay.
Minus 2, and they're all 3s.
Wow, this is ridiculous. Who created this problem?
Minus 6. Oh wait, hold on, minus 3. Yeah, minus 6 squared. Plus du over dr.
No, it's good. Hey, I'm doing it to myself. I wanted to do it. Plus 3u? 3u equals 0, right? All right. My hand hurts just from writing it down, right? Take your time. I'll give you 10 minutes to write it down. No, I'm kidding. That's ridiculous. This form's ridiculous. It's not that hard. The last one we did was harder, I think. That repeated complex root thing is really tricky. This is actually works out pretty nice, I think. It's rigged because it's a math class. Yeah, if I make these up, we can't do them. Oh, Aislinn, I'll give you your test. Nothing follows me. Oh, and Brian, I have yours. This thing isn't following me, so it's kind of nice. Oh, Giovanni, I have yours too. Oh, Robert, is there Robert here? Robert Donaldson? No? Okay. Giovanni! Here you go. Are you Italian or?
Yeah.
Oh, cool. Do you speak Italian? No. Oh, okay. Aislinn! Brian! Here you go. Wow, interesting perspective from over here. It's different. It's really messy. Okay. All right, what's the, it's bothering me now, like, oh God. There's a solution. I don't know how you handle it. Okay, so what do we write down first, that equation? What's it called, that equation? Characteristic or auxiliary equation, yeah. So it'd be m to the 5. Okay, plus 3m to the 4th. Minus 2m to the 3rd. Yep, good, Duncan. Minus 6m to the 2nd. Plus m. Well, plus m. Yeah, plus m. Plus m. Plus 3. Yeah, plus 3. And that's equal to 0. Good stuff. Fun times. So we have 6 terms. So I think we can pull stuff out, right? From things. Like here we can pull out an m to the 4th from these two. And then here we can pull out negative 2m squared. And then here we can pull out 1. And I think it's going to work. Let's see. So let's pull out m to the 4th. I've done this before, so that's why I feel so confident. But let's see. M to the 4th. Then we have m plus 3. Isn't that beautiful?
Okay.
Mm-hmm. It's nice. Yeah, it's like the ultimate factor by grouping problem. Minus 2m squared. And then we can pull, not pull anything out. It's just going to be m plus 3, right? 3.
Yes, it's actually a minus.
Is it? No, because minus and plus is minus, right?
Yes, you are correct.
Yeah, we put that minus
negative 2 out.
I did. I pulled the negative 2 out. See, negative 2m squared times m is negative 2m cubed. Negative 2m squared times positive 3 is negative 6m squared. See, no, it's good. Ask. Ask, it's important. Plus, oh, what do we pull out from this? 1. Uno. Yep. M plus 3. Uno. That's a game, right? Uno means 1 in Spanish. So. We have. Every time I say 1, I think about it. Yeah. In calculus 3, every time I'm teaching it, and I write 0 k hat for vectors, I think okay, like every single time. Like, it's like okay. Like, you do too much math. This is what happens. Your mind just. So now we can pull out m plus 3 from all of these, right? From every single one. M plus 3, m plus 3, m plus 3. Do you want to put the m plus 3 in the front, or do you want to put it in the back?
Back.
Really? Okay. All right. I usually don't do that. I usually put it in the, okay, all right. I'm going to, m to the 4th feels really weird. I'm going to do it. It just feels really awkward. And then, just got to walk away for a minute. I usually put it in the front. Every single, it's just habit, but it does check, right? It's easier to check it now too when you put it in the back. Look, m to the 4th times m plus 3, m to the 4th times m plus 3. It makes more sense. Negative 2m squared m plus 3, negative 2m squared m plus 3. 1 m plus 3, 1 m plus 3. Yeah. So, beautiful, right? What a beautiful problem. I love this problem. I'm really liking it because I haven't messed up. This should factor even more, I believe, right? Does it? I think it's m squared minus 1, m squared minus 1, m plus 3. You might say, why didn't you write m squared minus 1 squared? That was on purpose.
Can we still count that as repeating?
You can, but this can be factored further, right? M squared minus 1 is something else. It's the difference of squares. Yeah, this is the difference of squares. It's ridiculous. Let's factor it again, and then it's going to be repeating. So m squared minus 1 is m. I'm just curious, do you all write m plus 1 or m minus 1 first?
plus 1.
Everyone does that. I wonder why. Okay, m plus 1. I've noticed that.
Like to think positive first.
I always do m minus 1 first. And most people say m plus 1, m minus 1. Maybe the book has it that way, or maybe that's how it's taught. And I was just never taught. Or I forgot what I was taught, or something. Who knows? That's too many m's.
You were never taught math?
And I learned this in school.
Weird.
Yeah. I remember learning y equals mx plus b. I remember that. I remember struggling. Sitting at the kitchen table like, oh, rise over run. Like, oh, it sucks. Like, it was really hard. You can combine these, m plus 1, m plus 1, m minus 1, m. So that's going to be a multiplicity too. You want to combine them so you can see the multiplicity like this. So this is going to be m plus 1 squared, m minus 1 squared, right? Combining the m plus 1s and combining the m minus 1s. And then m plus 3, and that's equal to 0. What a fun problem. I'm really glad I did this one. We didn't really warm up. I think we did those little like baby problems at the beginning, then we just kind of jumped into it today, which is kind of nice. It's kind of nice. Any questions so far? We're almost there. This is a really good combining of the things, like Tony was saying. It's a good combination of everything. So.
I'm just looking at the multiplicities there, and I'm thinking, okay, how long is this going to end up?
Yeah, it's ridiculous. Yep. So this is negative 1. What's the multiplicity of negative 1? 2. Yeah, dos. Yeah. Do you speak Spanish, Kyle? Oh, multiplicity. I'm just curious. Multiplicity 2. I wish I could speak other languages besides those. 1. So multiplicity 2. Like Chinese. That'd be really cool. And then m equals, Russian. M equals negative 3.
Just trying to read those backwards R's in Russian.
Yeah, if I could speak Russian, I'd be like using it all the time in class. Like in Russian, m is, you know. So now we can write the answer down. So y equals c1 e to the negative x plus c2. So we're doing this one first.
Does the order matter at all?
It doesn't. The order doesn't matter. Good question. What goes next? X. Very good. X e to the negative x plus, and then let's do this one, c3 e to the 2x plus C4. It's explosive in movies.
Why is it you didn't
Where
bring
did you
this?
get to?
Where'd you get the 2 from? Yeah.
What 2? What?
The x's need to be r's too.
No! 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 This is ridiculous! No! 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 R! No! No!
Did you start this problem by saying you wouldn't make that mistake?
It's all right. Okay. All right. R e to the r. I want to talk about it. Plus.
That's 9 points today.
No. It's and then we don't need to talk about it. E to the what? What's the last one? No, it's not an x. It's not an x. It's -3. It's all right. You laugh now. Oh, we'll put this on the test, right? And there's a W here. Game over, right? Like, yeah.
Okay, so I have one question. Multiplicity is when it's just m equals and it's not a conjugate term. We add an x to the second one, like when we write.
Right.
But for the conjugate one, we just repeat cosine sine, no extra.
Right. Right. Each complex conjugate, each pair of complex conjugates gives you a cosine and a sine. So we did an example where we had a repeated complex root, so we had 2 pairs. Yeah.
We wouldn't have like beta x in the first and then beta x in the
No.
second, just beta x every time.
Right. Yeah. Yeah, the x's go outside the cosines and sine for the complex roots.
Shouldn't that y be a u?
Yeah. Yeah. So, yeah. But yeah. I'll give you the points. Yeah. Do you understand, Aislinn?
Yeah, could you write it out just for clarification?
Yeah, so like let's say, Aislinn has a really good question. She's saying like what if you had m equals 4? Well, let's just, if you have m equals 4 multiplicity 3, then you would have c1 e to the 4x, assuming we're using y's and x's like normal human beings, plus c2x e to the 4x, plus c3 x squared e to the 4x. Very good, right? So if that would be the case. Now, Aislinn's asking, so the complex one was different. We had like, if you had like 2 plus or minus 3i, so if it's just repeated once, it would be c1 e to the 2x cosine 3x plus c2 e to the 2x sine 3x. So in that weird example we did, we had multiplicity 2, so it was repeated. So we had to do it again. We had to do plus c3x.
Oh, so there is an x there. I don't think I copied that.
Yeah, e to the 2x. That's on the one that had that multiplicity 2. And then plus c4 e to the 2x sine, that's a 3. 3x. I got it. Okay, let's do something else. Sorry. Hey, it's okay. This test will probably be a couple hundred points just because of the material. So it's just that not because of me. Like the material just kind of dictates. I mean, some of the questions are, wait till you see 4-4. Like we'll have to use all 3 boards. This thing hopefully is fit. Well, I'll bring the pen. I mean, the problems are huge. It'll take us 30 minutes to do one problem. I was looking at a DE video from last year. It took 40 minutes to do one problem. 40 minutes, yeah.
Was this last one number 13?
Yes, I believe so. Let's do something a little bit different. There's some easier ones in the homework. So like number 20, it wants us to go backwards. So 20 is an interesting one. So 20.
Siphoning all my paper.
Siphoning it. It's like something like gasoline. I don't think people do that anymore. But siphon gas. It's like you could die, they say, right? If you siphon gas. C2. Oh, there's a right way to do it?
Yeah.
Really?
Yeah.
You have to show me. No, I'm kidding. So we're given a differential equation. This is a really easy one. Will this be on your test? I don't know. Maybe, if you want it to be on there.
It's easy because we're using y and x this time.
Yeah, because we're using y and x, not u and r. It's like So the question is to find the DE. Find the DE. Or find ADE, right? Find ADE. This is nice that we have time to do these today. We'll just work on 4-3 all day, I think. Next time we'll start 4-4, and the goal is next time to actually do one problem. If we can do one problem next time, like one's full DE, then we'll be able to finish everything, and then, yeah. Okay, so this is the solution to the DE, this here, right? So we have to find the m's from this. So the m here would be 1. What would the m here be? 4. So you write them down. So m equals 1, m equals 4. These are multiple choice in the homework. And you have 30 tries, so let's see. Gesundheit. I think I said it wrong. So these are the roots or solutions to the characteristic or auxiliary equation. That means that m minus 1 and m minus 4 are factors. So you can reconstruct the equation like this. So you're working backwards. You're given the answer, and it's really fun. Ooh, there's a really hard one we'll do after this. Well, harder. And I'll show you a way that this guy taught me. Then you can multiply it out. I'm going to show you how I do it. So m times m is m squared. And then to get the next one, I just do it all in one move, or multiple moves. Watch. Negative m minus 4m is negative 5m. Right? Negative m plus the inside and the outside give you the middle term. So negative m minus 4m is plus negative 4m is negative 5m. And then negative 1 times negative 4 is 4. I'm really nervous because I've messed up so many times today. It's all the r's and the t's. That's what's. I mean, that was the majority of the mistakes, right? Was the r's and yeah. Usually when I mess up once, I keep messing up. Everyone see how we got this? I see it rhymed, no one calling you out. Sorry. Okay, so now we can go to the derivative. So what derivative is the m squared going to give us? Second. Yeah, so y double prime. I just want to say prime, but no one says that. Y prime? Minus 5. Oh, what does the m become? Y prime. What about the 4? 4y. I know I have messed up on tests. Like there's been mistakes on tests, and whenever that happens, everyone just gets the points. Like I'll put this on the test, and I'll forget to put the y there. It's like, okay, everyone gets it right. So that's it. So just going backwards, just some easy ones going backwards. Okay, let's do another one. Let's try, let's see. Ooh, no, it's weak. Yeah, there we go, 23. No joke. So I'll show you, I think maybe the easiest way to do 23. So it's y equals c1 e to the negative x cosine x
Plus c2 e to the negative x sine x.
Thank you, sine x. Yeah, I used to do this a different way, and then there was a teacher, he retired. He was like, oh, let me show you how to do it. And he showed me this on a napkin. Like, this is how I do it. He had like a little napkin in his pocket, and he showed me the technique that I'm about to show you. So check this out. So you have to find your alpha and beta from this. So what would alpha be in this case? -1, good. What about beta? 1, yep. So the answers are of the form alpha plus or minus beta I, right? That's our m. That's what m is. So I'm going to plug in the numbers. So m, this is how he did it, is -1 plus or minus I. I'm trying to remember how he did it. Okay, I remember. Because if you do it like this, it becomes hard. Like you could do it like this, like m minus something times m minus something, but watch this. So the way he taught me was that you solve for the I part. So you add 1 to both sides. So you get m plus 1 equals plus or minus I. I say, why are you doing that? You'll see, I'll show you. It took me a minute. When he did this, I was like, whoa, because my way is way harder than this. It is way more involved. And then you square both sides. It's kind of clever. I'm like, what, you're squaring the plus or minus? Yeah, you can. You can do whatever you want, right? I mean, it's math, as long as...
So if you had a coefficient multiplied by I, you would deal with that before you go...
No, you would leave it there.
Oh, you would leave it?
So we're squaring the plus or minus I. I'm like, whoa, that's bold, you know? And apparently this is the way he taught it, like in his college algebra class. I was like, oh, hardcore. Like, it's real pro. So you can multiply this out. There's a trick, right? You square the m. You multiply these two and double them. So 1m times 2 is 2m. It's a formula. And then you square this one, so you get 1. It's that formula. I'm sure you know it, but I'll write it. It's a plus b squared is a squared plus 2ab plus b squared. That's that formula. Yeah, I remember learning that. It took me years to learn that formula because I didn't want to learn it. And this is equal to, when you square the plus or minus, it just becomes plus, right, because it's squared. So that's going to go away. What happens when you square the I? What's that going to become?
-1.
So this is a -1. That's the part that I always thought was a bit tricky. It's like, oh, what about the plus or minus? No, you're squaring the plus or minus, right? You're squaring whatever's there, and it's going away, so that becomes a -1. Really sneaky, really sneaky. Then you just add 1 to both sides. So +1 + 1, so +1 + 1. So we end up with m squared plus 2m plus 2 equals 0. Yeah, equals 0. Yeah, no doubt.
Just turn it into y's.
Now turn it into y's. Yeah, and derivatives, very good. So this will be y double prime or prime prime plus, let's do y prime plus 2y. 2y. Yeah, the 2 becomes a 2y, so that's always a tricky step, and that's equal to 0, and that's it. That's it. That's it. That's it. And that's the hardest one, I think, perhaps. That's in the homework. Any questions on this one? Okay. 25 is like a challenge question. That's a really, we'll talk about that later. It's like a harder one. Let's see, what else can we do? There's some really nasty ones here. I see, said the blind man. What is going on there? Maybe we should do something else. How about just look at the answers to the homework and try to find, we have 11 minutes. Maybe we could do one more. Because what's today, Wednesday? Yeah, okay. I think I should do an initial value problem then, because they're a little bit longer, but yuck. What is going on? Oh no, I'll leave that one to you. That one's not that bad. It's looking.
Would you be doing initial value both ways?
Yeah. What do you mean? No. No. Let's just try. I guess I'll just take a chance and pick one. Let's do 18. 18 is a boundary value problem. Let's do 18. 18 might be nasty. I don't know. Let's find out. Let's just do it. So 18 is, oh, Nikki, you're there. Hey, hello.
Y double prime minus 8y prime plus 16y is equal to 0, and then you have y of 0 is 1, y of 1 is 0.
Y of 1 is 0. Thank you, Nikki. This one's actually pretty tough, I think, but it's too late. We're going to do it. So I think something difficult might happen. Like it's going to be a little bit harder than I anticipated, but we can do it. There's going to be a product rule, I think, at the end. There'll be a derivative where we have to do a product rule. And they say, how do you know that? I'm just thinking, this is going to be m minus 4 squared. So it's going to give us m equals 4 multiplicity 2. So we'll have an x e to the 4x. So, oh, wait. Never mind, there's no derivative. It's a boundary value problem. So, okay, ignoring all that, let's do it. Solution. First thing we have to do is write down the characteristic equation. That would be the first step. So it would be m squared, right? M squared minus 8m plus 16. And that's equal to 0. Did that right? Looks okay. No T's, no U's, no R's. Life is good. And then you get the test, like there's no Y's and X's anymore. Like, what is he doing? Like, payback. So that's so bad. I would not do that. So this factors, right? It's m minus 4 squared equals 0, I believe. Okay. Yeah, I was concerned about the taking derivatives, but they're both conditions on the initial function. It's kind of interesting. This is called a boundary value problem. That's because these numbers are different, and the conditions are both on y. There's no y prime here. Usually there's a y and y prime. So m equals 4. What's the multiplicity in this case? 2. Yeah, 2. Dos. So multiplicity 2. Multiplicity 2. Okay, so write the answer down. So it'd be y equals c1 e to the 4x plus, and then it would be c2 x e to the 4x. I was thinking about something else. I was thinking, how do you say e in Spanish? Like e to the 4x. I wonder how do you... but how do you say e to the 4x? Anyone know?
To the 4x.
Yeah, e to the 4x. I know it's 4x, but I don't know, like, I don't know. Anyways, if you try to do math in Spanish, it's really hard. I've done it. Okay, so now we have to use our conditions. So this is the solution to the DE, right? So now we have to find the C's using this. Fun times. So let's see. Let's use our first boundary condition. That's what they're called. It's kind of exciting. So y of 0 equals so it'd be c1 e to the 0. So c1 e to the 0. Oh, what's this going to become? 0. It's so good. So plus 0, because it goes away, because x is 0. I was worried about it. I'm like, no, it's going to be hard. And this is equal to 1. Right, so just plugging in 0 here for all of the x's. Right, 0, 0, 0, plugging in 0. So you get c1 e to the 0 plus 0. So you get c1 equals 1. I'm going to put that in a box. Hey, hello, Mike. So now we just have to use our other boundary condition, y of 1 equals 0. So y of 1. So y of 1. So again, we're plugging it in here. This is kind of unusual. Usually we have to take derivatives. Again, most of the time in the homework, you have a y prime here. Okay, so it'd be c1. C1 e to the 4, right?
Could you just put a 1?
Yeah, you want to just put a 1 there instead of the c1? We can do that? Okay, so it'd just be e to the 4. I'll put 1 e to the 4. Plus c2, we're plugging in 1, right? So we just get 1 e to the 4. And that's equal to what? Cero. Oh, wow. Cero, right? In Spanish. Yeah, good. Yeah. Good stuff. All right, any questions so far on this one? So subtract the e to the 4. So you get c2. I have a couple of videos in Spanish, and they have a lot of dislikes. Subtract this. Yeah. Yeah. One of them has like 1,000 views. The other ones, no one watches them. You divide by like 10 views. Divide by e to the 4. c2 equals -1. That worked out really nice. Look at that. That happened. It makes me feel like we're doing it right? Because we divide by e to the 4, right? Divide by e to the 4. Boom, boom. Beautiful stuff. So c2 is -1. So now we can plug them back into our solution, right? You just plug it back in here, and we're done. And we've solved this problem. I don't think I've ever done this problem in class, ever. Ever. Like, not once. I don't know why we chose to do it today, but I think it was good. So e to the 4x, right? Because it has a c1 is 1. And then c2 was -1. So it'd be minus x e to the 4x, like that. And that would be the solution to the problem. Any questions or mistakes? I feel like I've never done this problem before. I think I did this problem the first time I made my notes, which was like thousands of years ago, and years ago, and I never did it again until now. So we have 4 minutes. So any questions? You think you got this stuff? Think you could do it?